The next problem is from chapter 13, and it is problem 1. And it says the depth of water behind the Hoover Dam in Nevada is 220 meters. So we have H equals 220 meters. What is the water pressure at the base of this dam? And it says in parentheses, neglect the pressure due to the atmosphere. I'll make a comment on that later. So we look up the equation for that, which says that the pressure equals the weight density times the depth. And we find that the weight density of water is 9,800 newtons. That comes from that 1 cubic meter of water is 1,000 kilograms, and then because of gravity we multiply by 9.8 times the depth, which is given as 220 meters. And when I do that on the side on a calculator, I come up with 2,156,000, or around it 2.2 million Newton meters, or the unit would be pascals. Of course, I only need two significant figures. If I don't want to write down a big number like that, I could also write this as 2.2 megapascals. By the way, the atmospheric pressure is 100,000 pascals, so due to the depth here, the water pressure at the bottom is 22 times higher than atmospheric pressure, and I wouldn't neglect it, but what happens is that we would have atmospheric pressure on top of the lake, as the lake meet, and then we have atmospheric pressure at the bottom where the water is coming out. So atmospheric pressure is pushing in on the top, and it's pushing in from the bottom, and because it's pushing from two different directions, that actually cancels out, and perhaps that's what they meant by saying neglect. So the total pressure is actually 2.2 megapascals. So next problem is number 2, chapter 13, number 2, and it says a 6 kilogram piece of metal displaces 6 kilogram piece of metal displaces 1 liter of water when submerged. What is its density? So it has a mass of 6 kilograms, and it displaces, when submerged, 1 liter of water. And an object that sinks will displace an equal amount of water, a volume of water equal to its own volume. So that means it displays, as it displays 1 liter of water, its own volume is also 1 liter. So we do the density is 6 kilograms divided by 1 liter, which comes out to 6 kilograms per liter, or 6 grams per cubic centimeter. The reason is that there's 1,000 grams in the kilogram and there's 1,000 cubic centimeters in the liter, so the two conversion units cancel each other, and that's why we come up with the same number here. So 6 kilograms per cubic centimeter.